Good evening. In the next 5 minutes, I'm going to try and convince you why my electrical engineering job is not as boring as my family and friends think it is. And that's why I tried so hard to title my talk to something that would not put you all to sleep. So, bit of a disclaimer just before we get it out of the way. The title Flashes and Bangs should not prompt you to think that I'm going to be talking about flashbangs, or fireworks, or bombs, or hand grenades, or gunshots. The presentation is actually a lot dull than that. What I will talk about, however, is arc flash. You know, the life safety factors that are going ahead with it. What are the involvement of the electrical equipment, the financial impact, what are the arc flash studies, how you conduct them, and some safety measures that we can use to protect ourselves. Arc flash is actually the energy released during an arcing fault. So this happens when current flows through a medium that is not intended to conduct electrical current, like ionized air. And the results are often violent, like serious injury and even death. To give you an idea about how hot arc flash incidents can be, within a millisecond, temperatures can reach 35,000 Fahrenheit. That's like 4 times the temperature of the sun. The only good news is that it lasts for a short duration, so the pain, while fatal for the worker, is short-lived. If you're still not convinced why arc flash is dangerous, maybe I can use some stats. There are fiery explosions, more than 2,000 burn victims annually, numerous deaths, financial havoc in the forms of fines, lawsuits, and damage. And within the span of milliseconds, there's a lot of stuff coming out. Blast pressure waves at 140 decibels can throw workers across the rooms. There is molten metal at speeds exceeding 700 miles per hour, propelled up to 10 feet. Here's a sobering fact. A total of 30,000 arc flash incidents happen every year, and about 5 to 10 incidents occur every day in the US. 2 out of these 3 incidents are because of inappropriate actions of a worker. So there's clearly something that we can do to make these things better. Take a look at the garments of a worker after an arc flash incident. The injuries, they can range from 2nd and 3rd degree burns, severe damage to respiratory systems, blindness, vision and hearing impairment, and skin ruptures from flying debris. Other impact includes severe damage to electrical equipment, delays and downtime caused by OSHA fines, and there's further hampers the productivity. And there's not a lot of people who want to work in such a place, which is an unsafe place, frankly. So speaking about financial havoc, here are a few examples of OSHA fines. PAI industry was fined about $55,800. There was Nixon Brakes, an automotive company, that was fined $53,000, and McAfee Electric was fined $51,000. And this is aside from the people and equipment damage that happened to these companies. So 2 equations are very important when conducting arc flash studies. One is, of course, the incident energy for NFPA 70E, and the other is arcing current from IEEE 1584. There's quite a lot of factors that go in here, so you can see how fast I made the switch from fun stuff to boring. 2 standards are here, NFPA 70E and IEEE 1584. They're very helpful because NFPA tells you what kind of PPE to wear, and IEEE 1584 tells you how to actually calculate incident energy and arcing current. There's a lot of software which we can use, but more importantly, the arc flash labels which are stuck on these equipment, they're very informative because they can keep the worker safe and they can teach how to energize the equipment, especially when it is energized, or how to operate all that stuff. More stuff. So in residential environments, where are my notes? Okay. At our homes, using an arc flash circuit interrupter, it's very helpful because they can detect dangerous currents. And it's very helpful if you use your non-dominant hand, and it should be dry as well. For a lot of people who have solar at their homes, there's a risk of arc flash in their solar PV modules, but the solution is using an arc box. Why? Because this kind of an arc box can contain the arc within a small space. So you're able to protect yourself, you're able to protect your equipment. There's 4 kind of categories for arc flash. There's from 0 to 4 calories per square centimeter for category 1, and similarly for category 2, 3, and 4. Now, there is 2 kinds of things. One is the clothing, and the other is protective equipment that you wear on top of clothing. So that's going to protect you from very severe kind of accidents. So even if you do get yourself in such a situation where you're working on live equipment, make sure you ask yourself these questions. And the most important of them is, of course, having some sort of a backup, in case you die. So reducing arc flash in operation, these are some of the ways which you can do that. If you're not an electrical engineer, it's okay, hire one. So most importantly is, of course, making sure that you're doing everything remotely if you're not able to do something in person. Finally, just remember these 5 steps. First is, of course, getting an arc flash study done, get the right electric permit, wear the PPE, get your installator tools, get the safety program, and don't do what Scotty is doing right here. Thank you.